After studying this module, you shall be able to know the significance of digital watermarking, the incorporation of watermarking to a digital image, the various categories of digital watermarks. The term digital watermarking follows the term watermarking, which is believed to have been incepted long back. Watermarks are distinguished marks or designs or patterns impressed on a paper during manufacturing process by making thinners, line or white watermarks, or thickers, which are shadow watermarks, on the layer of pulp when it is still wet. Watermarks are visible when paper is held up to the light or in some cases over a black surface. Example, currency note, bond paper, stamp papers, etc. The objective of watermarks in paper is essentially identifying the paper as a signature of the manufacturer or as a security measure to avoid forgery of important documents. The origin of the water part of watermarks can be found back when a watermark was something that only existed in paper. At that time, the watermark was created by changing the thickness of the paper and thereby creating a shadow or lightness in the watermark paper. This was done while the paper was still wet or watery, and therefore the mark created by this process is called a watermark. Indeed, watermarks are a good help in the study of old documents as they can suggest their origin or date. Now, in the particular image, you can see the cigarette paper with watermarks. Now, in the next image, you can see official papers with watermarks. Now, the currency note displaying the watermarks in them. Initial application of watermarking was also information hiding for passing secret messages. Information hiding started with steganography, is the art and science of concealing messages into something innocuous in such a way that it is extremely difficult for someone to suspect, let alone find, except intended recipient knowns of the existence of the hidden messages. Now, digital watermarking. Digital watermarking is the process by which identifying data is woven into media content such as images, movies, music, or other multimedia data by a certain algorithm, given those objects a unique digital identity that can be used for a variety of valuable applications. Imperceptible to the human senses yet easily recognized by simple software detectors, a digital watermark remains constant even though recording, manipulation and editing, compression and decompression, encryption, decryption and broadcast without affecting the quality of the content. A digital watermark added a photo is more or less visible information in the form of a text or some other photo image that has been added to the original photo. The added information can be more or less transparent to make it either easy or hard to notice the watermark. Now, in this particular image, you can see digital watermarking. In this, an original digital image is taken and covered digital watermark is embedded in this. Now, then in this image, digital watermarking is displayed and original digital media is taken, and in this covered digital watermark is embedded. Now, we can get a digitally watermarked content. So, a digital watermark is a lot like the metadata that is invisible and attached to an image. Unlike metadata, it is much more difficult to remove and it stays with an image even though all types of manipulation like copying, cropping, editing, compression and decompression, encryption and description without affecting the quality of the image. Now, the incorporation of watermarks in digital image. A transparent watermark is added to a photo by changing the image on the pixel level. A pixel is one dot of the image. The pixel that will make up the resulting watermark is changed more or less in the direction of the watermarking image. If, for example, the watermark is 50% transparent, 50% of the RGB, which means red, green and blue values are detected from the original image and 50% of the RGB values from the watermarks are added to the image. Now, in this particular image, you can see the original digital image is there. Now, digital watermark is embedded into it. Now, we get an digitally watermarked content which can be used in movies, music, images, prints and for television and radio broadcast. Now, significance of watermarks in digital photography. A watermark is added on a digital photograph with the intention that it should not be copied or used without the consent of the author or the originator. Also, if a highly visible watermark is added along with an almost hidden one, it will much more be easy for the thief to overlook the invisible and thereby adding more protection to the image. There has been a lot of research into adding an invisible watermark to images that is hard to remove again. But many of these programs do not work on JPEG images since these are transformed into the compression of the image. Many companies are working on the option of adding a hidden watermark to the image. The basic characteristics of digital watermark are imperceptible, security, reliability, low complexity of watermarking algorithms and security of the hiding place. Digital watermarking algorithm is composed of three parts. First is watermark embedding algorithm. Second is watermark extraction algorithm. And third is watermark detection algorithm. Now, digital watermarking is a technology that opens new doors for users whether watermark can be reliably detected after performing some media operations. In this, the first is perceptual transparency. This property describes that whether watermark is visible or invisible to human sensor organ. Perceptible watermarks are visible to human while imperceptible are not. Imperceptible watermarks are such that content remains same after applying digital watermarking technique. Perceptible watermarks, which means visible one, are extension of the concept of logos. They are applicable to images only. These watermarks are embedded into image. They are applicable in maps, graphics and software users interface. Imperceptible watermarks are useful for content or author authentication and for detecting unauthorized copier. Now, the second is security. Security property describes that how easy to remove a watermark. This is generally referred to as attack on watermarking. Attack refers to detection or modification of watermark. Now, the third is complexity. This is important property which is to be considered in real-time applications like videos. Complexity property is concerned with the amount of effort needed to extract or retrieve the watermark from content. Now the next is capacity. Capacity property of digital watermark refers to amount of information that can be embedded within the content. If more data is used in watermark, it will become less robust. Now the next is robust watermarks and fragile watermarks. Robust or fragile is nothing but a degree to which watermarks can withstand any modifications of any types caused due to the transmission or loosey compression. Perceptible watermarks are more robust in nature than imperceptible ones. Robust watermarks are those watermarks which are difficult to remove from the object in which they are embedded. Fragile watermarks are those watermarks which can be easily destroyed by any attempt to tamper with them. Fragile watermarks are destroyed by data manipulation. Now the next is private watermarks and public watermarks. Private watermarks require at least original data to recover watermark information. Public watermarks require neither original data nor embedded watermarks to recover watermark information. Private watermarks are also known as secure watermarks. To read or retrieve private watermark, it is necessary to have secret key. Public watermark can be read or retrieved by anyone using a specialized algorithm. In this sense, public watermarks are not secure. Working of digital watermarks. Digital watermarks provide the means of hiding steganographic messages for many different purposes. Now in this chart you can see an original image. In this, an original watermark is embedded, which is the security key. Now the watermarked image has to be extracted with the security key, which is the extracted watermark signal. Data with D, watermark with W, stego key with K, watermark data with DW, embedded D, W or K is equal to DW. Now extract DW is equal to W and compare with W. Example, find the linear correlation and compare it to a threshold. Now how do we make this system secure? A stego key or K is secret. Use cryptography to make information hidden more secure. Example, embedding DW is equal to D plus W. Now the matrix representation. 12 blocks is given by 3 into 4 matrix. The algorithm used is random number generator RNG. Seed for RNG is equal to K, D is matrix representation and W is the author's name. The example is extraction. Now the watermark can be identified by generating the random numbers using the seed K. Now data domain characterization. In this, the spatial watermarking. Direct uses of data to embedded and extract watermark. Example, voltage values for audio data and to transform based watermarking. Conversion of data to another format to embedded and extract. Example, conversion to polar coordinate system or 3D modules make it robust against scaling. Now extraction characterization. In this, informed or the private is given by extract using D or K or W. Now in semi-blind or which means semi-private. In this, extracts are used K or W. Now the next is blind or public. In this, the extract using is K. Blind requires less information storage. Informed techniques are more robust to tampering. Now, robustness categorization. Fragile for tampering proofing. Example, losing watermarks implies tampering. In semi-fragile, robust against user-level operation. Example, image compression. Now, the robust against advisory-based attack. Example, noise addition to images. Now, the characterization of watermark. In this, the example 1 is robust private spatial watermarks. Example 2, blind fragile DCT based watermarks. Example 3 is blind semi-fragile spatial watermark. Now, the categories of digital watermarking. In this, the spatial domain method. The spatial domain is the normal image space in which a change in position in one directly projects to a change in position in space. Distances in 1, which means in pixels, corresponds to real distances, example in meters, in space. This concept is used most often when discussing the frequency with which large image values change, that is, over how many pixels does a cycle of periodically repeating intensity variations occur. One would refer to the number of pixels over which a pattern repeats its periodicity in the spatial domain. Here we use least significant bit LSB method. Now the transform domain method. They produce a high quality watermarked image is by first transforming the original image into a frequency domain by the use of Fourier discrete Cosine transform, which is represented by DCT, or discrete velvet transforms, which is represented by DWT. With this technique, the marks are not added to the intensities of the image but to the values of its transform coefficients. Then inverse transforming the marked coefficients form the watermarked image. The use of frequency based transforms allow the direct understanding of the content of the image. Therefore, characteristic of the human visual system HVS can be taken into account more easily when it is time to decide the intensity and position of the watermarks to be applied to a given image. Now, least significant bit. One of the simplest technique in digital watermarking is in spatial domain using the two-dimensional array of pixels in the container image to hold hidden data using the least significance bits, which is represented by LSB method. Note that the human eye are not very attuned to small variance in color, and therefore processing of a small difference in the LSB will not noticeable. The step to embed watermark image are given. Steps of least significant bit. Convert RGB image to grayscale image. Make double precision for image. Then shift most significant bits to low significant bits of watermark image. Then make least significant bits of host image to 0. Then add shifted version of watermarked image to modified host image. Now, limitations of spatial domain watermarking. This method is comparatively simple, lack the basic robustness that may have been accepted in any watermarking applications. It can survive simple operations such as cropping, any addition of noise. However, logic compression is going to defeat the watermark. An even better attack is to sell all the LSB bits to one, fully defeating the watermark at the cost of negligible impact on the cover object. Furthermore, once the algorithm is discovered, it would be very easy for an intermediate party to alter the watermark. Now, discrete Cosine transform watermarking. The DCT allows an image to be broken up into different frequency bands, making it much easy to embed watermarking information into the middle frequency bands of an image. The middle frequency bands are chosen such that they avoid the most visual important parts of the image, which is low frequency, without overexposing themselves to removal through compression and noise attacks. Now, the steps of DCT watermarking. The basic idea of the DWT for a one-dimensional signal is that a signal is split into two parts, usually high frequencies and low frequencies. The edge components of the signal are largely to the high frequency part. The low frequency part is split again into two parts of high and low frequency. This process is continued an arbitrary number of times, which is usually determined by the application at hand. Now, the steps of DWT watermarking. In this, the first step is the first part of the watermarking process is of course the encoder. The first step is to decompose the image into 4 frequency bands using first resolutions of hair velvets at first level. In the second level, decompose image into 7 frequency bands using second resolutions of hair velvets. At 3 level, decompose image into 10 frequency bands using third resolutions of hair velvets and so on. The next operation is to add a pseudo-random sequence and, in fact, a Gaussian distribution of mean 0 and variance 1 to the coefficient of the medium and high frequency bands. The normal distribution is used because it has been proven to be quite robust to collusive attacks. Now, the digital watermarking applications. Copyright protection to provide the ownership of digital image. Next is hidden watermarks represents the copyright information. Next is tamper proofing to find out if data was tampered, example change meanings of image. Next is hidden watermarks track change in meaning. Now, image authentication. At first, a semi-fragile watermarking is embedded into the image for authentication and integrity checking purpose using a QIM scheme integrated in a JPEG 2000 coder. Next, the image is JPEG compressed at default quality level in order to stimulate a common unintentional attack and then maliciously manipulated using the GRIMP. It is the task of the watermark detector to indicate only those regions that have been modified to change the content or meaning of the image tamper detection. Now, content protection and digital watermarking. Digital watermarking provides an added layer of security to the content protection chain to deter unauthorized use of content by embedding watermarks that identify the permitted use of the content into the music or motion picture soundtrack prior to the theatrical, packed media, Blu-rays disc, DVDs and online digital distribution. Devices read the watermark during playback or copying of content. If the watermark indicates that the use is unauthorized, the playback or copying is stopped or the audio is muted and an explanatory message may be displayed. Now, the forensic and piracy deterrences. Forensic watermark application enhance a content owner's ability to detect and respond to misuse of its assets. Forensic watermarking is used not only to gather evidence for criminal proceeding but also to enforce contractual uses agreements between a content owner and the people or companies with which it shares its content. It provides positive, irrefutable evidence of misuse for leaked content assets. Watermarking can also complement digital rights management (DRM) by balancing content owner copyrights with consumer fair use allowance. Now, working procedure. A forensic application embeds the identity of a recipient into an asset's copy, which is the forensic report, at the time it is produced or transmitted. Sophisticated forensic applications embed situational metadata such as transmission time, receipt format, and recipient IP address. Some watermark applications embed a distinct forensic watermark at each stage of content distribution, enabling pinpoint accuracy. When a leak is discovered or suspected, the forensic watermark retrieved from the leaked copy identifies the intended recipient and provides evidences in the form of situational metadata that the copy was delivered to its intended destination. The evidence can be used to trigger contractual provisions or as legal evidence in a criminal action. Now, the use of digital watermarking for forensic and piracy deterrence help companies. In this, create a powerful deterrence for leaking content either maliciously or unintentionally. Then quickly and accurately identify the source of leaked content. Then provide irrefutable evidence of content misuse in support of legal action. Then gain visibility over where and how their content is being accessed without the need of a complete DRM system to restrict access. Now, content filtering includes blocking and triggering of actions. The experience of watching television has radically changed over the last few years. Today, people want to watch content in their own time and place. The proliferation of set-top box, which is STB, in homes evidences this, as people want to watch video on demand on a time-shifted schedule. Digital watermarks offer new opportunity for content owners, advertisers, and more generally marketers looking for new ways to engage consumers with richer media expressions for STB and television sets. Now, the copyright, communication and digital watermarking. Watermarks stays with content as it is forwarded and travels across the internet and can be detected at any point to determine the content's unique identity. Watermarks also survive many different files, manipulations and transformations, unlike standard metadata that is often lost, leaving the content orphaned. Now, the effective copyright communication helps content owners. This ensures their ownership and contact information stays permanently attached to their content wherever it may travel and be accessed on the web or packaged media. Monetize their content with opportunities to add automated licensing to increase revenues. Better manage content through a range of automated remedies when unauthorized use is discovered, including device enforcement messages and copyright policies. Take down notices of providing permission with proper attribution. Protect their content from being an offensive work whose origin is unknown. Now, the document and image security and digital watermarking. Digital watermarking enables corporations and brand owners to embed a unique digital ID into confidential documents and digital images. For instance, a unique digital watermarks can be easily embedded into each copy of a confidential document as they are being created and distributed. The data contained in the watermark can include who the recipients are of each copy, so that any information that is inadvertently or intentionally leaked out is easily tracked back to the source. Finally, watermark detectors can be included in various printers, scanners, and other devices to check for watermarks in confidential documents that someone is attempting to copy. Now, effective document and image security helps companies identify each copy of a confidential document and image with a unique digital identity. Then trace back to the source of leaks if sensitive materials are distributed intentionally or inadvertently. Now, filter documents being uploaded to the web or forward in emails to quick identify confidential materials and stop distribution. Then prevent the copying of confidential documents or copiers and scanners. Now, the authentication of content and objects includes government IDs. The impact of counterfeiting is significant both in terms of lost revenues for businesses and fraud to the consumer, which can even endanger citizens in the case of counterfeit pharmaceuticals. When used as a part of linked and layered security approach, can provide a strong and effective deterrence of counterfeiting and help to solve this costly and challenging problem. Now, effective authentication of content, IDs and objects help companies. In this, the first point is reliably authenticate documents, objects and personal IDs at points of inspection. Next is to ensure the shipment travel their intended route and arrive at the proper destination. Next is immediately identify possible tampering and counterfeiting when the watermark is absent. Now, the broadcast monitoring. Over the last few years, the number of television and radio channels delivering content has notably expanded, and the amount of content flowing through these media vehicles continues to grow exponentially. Now, digital watermarks in a content tracking environment. Watermarking is an innovative technology that has proven to be highly valuable to content owners, producers, copyright holders and broadcasters throughout the world. By embedding a digital watermark in audio or video content at the time of production or broadcast, it allows content owners, for example, to identify with granular precision when and where content is broadcast, who is broadcasting and how far long. Digital watermarking works by making very subtle modification to the original assets by adding some bit data disseminated throughout the content. The modifications are indiscriminable to human senses but can easily be detected and decoded using dedicated hardware or software. Being part of the content itself, any attempt to destroy or remove it will also ruin the quality of the material in which it is embedded. Now, digital watermarking helps content owners and copyright holders to evaluate the true reach of media assets, to confirm and prove content broadcast and usage, to determine contractual compliance, to to immediately identify new skills opportunities, to identify potential misappropriations of assets, to communicate content rights and intent. Now, digital watermarking helps broadcasters and agencies to verify contracts and invoices for ultimate accuracy and accountability, to reduce in-flight discrepancies by improving media stewardship. Now, digital watermarking helps key broadcasters and networks to electronically verify affidavits, invoices, to replace electronic or manual affidavits, to compare schedules versus detections for faster invoice development, and to report or electronically transmit available affidavits or invoice databases. Now the summary. The objective of watermark in paper is essentially identifying the paper as a signature of the manufacturer or as a security measure to avoid forgery of important documents. Physical stenography has been in use since ancient times and include invisible ink, Morse code on knitting yarn which was then made into garments, microdots, messages on the back of postage stamps and more. Digital watermarking provides an added layer of security to the content protection chain to deter unauthorized use of content by embedding watermarks that identify the permits uses of the content into the music or motion picture soundtracks prior to theoretical packaged media like Blu-rays, discs, DVDs and online digital distribution. Forensic watermark application enhance a content owner's ability to detect and respond to misuse of its assets. Forensic watermarking is used not only to gather evidence for criminal proceedings, but also to enforce contractual usage agreements between a content owner and the people or companies with which it shares its content.